Hello students, welcome to Physical Science Digital Classes Mahabubabad. Myself Narendrababu PGT Chemistry TSMS Mahabubabad. Today, Human Eye and Colorful World. Class 10 Part 8. In this session, we are going to discuss about finding the refractive index of the prism lab activity. Finding the refractive index of the prism lab activity. Materials required: prism, pins, scale, pencil, protractor, piece of white chart. Coming to the procedure. First, take a prism and place it on the white chart and draw a line around the prism using a pencil. Remove the prism. First take a prism and place it on the white chart and draw a line around the prism using pencil. We have to draw a line around the prism using pencil and remove the prism. And the shape of the outline drawn is a triangle. See here, it is a triangle. Name its vertices as P, Q, R. Name its vertices as P, Q, R. So the refracting surfaces could be rectangular in shape. Here, the shape of the outline drawn is a triangle, but the refracting surfaces that could be rectangular in shape. Actually, refraction takes place at here. That means this end is this is the rectangular in shape. Find the angle between PQ and PR. So this is the PQ and this is the PR. Find the angle between the PQ and PR planes. And this is the angle of the prism A. So find the angle between PQ and PR, and this is the angle of prism A. Mark M on the side of the triangle PQ. This is the PQ. So along the side of the PQ, mark M at this position and also draw a perpendicular to PQ at M. Draw a perpendicular to the PQ at M. Place the center of the protractor. Place the center of the protractor at M, at this M position. Place the center of the protractor M and along the normal and mark an angle of 30 degrees and then draw a line. Now mark an angle of 30 degrees and draw a line. So up to M. Now draw a line up to M. This angle is called angle of incidence. Note, this angle is called angle of incidence. Note it in your table. This line denotes the incident ray. Place the prism in its position now. Now, after drawing this line, place the prism in its position again. Now, fix two pins vertically on the line at points AB. So, at these points AB, place two pins. Place two pins at points AB vertically. Vertically you have to place the pins to this at AB points. Look at the images. Now we have to place the pins at this side and we have to come other side and look at the images of the pins through the prism. So through the prism we have to try to see the images of the pins from the other side, that is PR side. And fix another two pins at point C and D. At point C and D, we have to fix another 2 points. So how do we know the point C and D? In the sense, when you are observing the images from other side, these AB and CD, these 4 pins appear to lie along the same straight line. If you are observing from other side, from this side, these 2 points at the same time, and AB points also appears to see on the same straight line, and at those positions we have to place this, we have to take the CD points, and at these points we have to place the again 2 pins vertically. Do it carefully. While doing this we have to take care of it. Now remove the prism and take out pins. Now Draw a line joining two pinholes formed by the pins to meet surface PR. Now, so after removing these pins, the pinholes will be present, and now we have to draw a straight line or draw a line which is joining to the pinholes formed by the pins to meet surface PR, and we have to continue this line until to meet the PR like this. We have to draw a line, straight line, okay, where it meets, and that point we have to consider as N. So this is the emergent ray actually. This is the emergent ray which emerges from the surface PR at point N. At point N, so this ray is emerges from this surface PR. And if you draw a line and perpendicular to this PR, then we can consider it as the normal. The angle between the normal at N and the emergent ray is the angle of emergence. So this is the angle between the normal to the emergent ray is called as angle of emergence. Measure this angle and note its values in the table. Now measure this angle and note its value in the table. Now join the points M, N by a straight line. Now join the points M, N by a straight line. The line passing through the points A, B, M, N, C and D represents the path of the light when it suffers refraction through the prism. The line passing through the points A, B, the lines which are passing through the A, B, M, N, C and D, they represents the path of light when it suffers refraction through prism. Extend both incident and emergent rays till they meet at a point O. Now extend this incident light ray and emergent light ray. Extend both incident light ray and emergent light ray. So they will meet at point O. So if you extend them, so these two light rays meet at point O. This is the point O. Measure the angle between these two rays. Now try to measure the angle between this incident ray and the emergent ray. Okay, so thus the angle of deviation we will get. So this is the angle of deviation. So it is denoted by a letter D. The angle of deviation will be denoted by the letter small d. So what is the angle of deviation? Angle of deviation is the angle between the incident ray to the emergent ray, and this angle of deviation will represent with the small d. Repeat the same experiment or activity. Repeat the same activity for various angles of incidence such as 40 degrees, 50 degrees, etc. So here we have taken the 40 degrees. Again we have to draw a triangle by using the prism, outline of the triangle, and now we have to take the 40 degrees angle and try to find out the emergent ray angle. Emergent ray, that means angle of emergence. At the same time 50 degrees again, and 60 degrees again, 70 degrees again, like that for different angles we have to do this same and note down the readings and find the corresponding angles of deviations, and after that we have to find out the corresponding angles of deviation and angles of emergence and note them in table. So this is the table. So in this table 30, 40 and 50, 60, 70, 80, like that we have to take the incident angle, and we have to find out the emergent angle of emergence and angle of deviations. Okay, right. Now after doing this activity at different angles, you will notice that the angle of deviation decreases first and then increases with the increase of angle of incidence. First the angle of deviation decreases, and after doing this activity, and slowly it decreases, and after that it increases. Okay, so as the angle of incidence increases after a certain value, and angle of deviation increases. Take angle of incidence along x-axis. Now this angle of incidence you have to take on x-axis, and angle of deviation on y-axis. Angle of deviation on y-axis. Using a suitable scale, mark points on a graph paper for every pair of angles. Every pair of angles means on x-axis we have to take the angle of incidence, and on y-axis we have to take the angle of deviation. And finally join the points to obtain a graph. And if you observe here, angle of incidence we have to take on x-axis, angle of deviation on y-axis. So for angle of incidence, for example, 30 degrees, what will be the angle of deviation? And 40 degrees, what is the angle of deviation? And 50 degrees of incidence, what is the angle of deviation? Like that we have to mark the points. Okay, finally all these points we have to join all these points, then we will get the graph like this. First we will get the high values, and after that slowly the angle of deviation values decreases to a certain level, and after that angle of deviation values increases by increasing the angle of incidence. Clear? So like this, it increases like this. First decreases and later increases. Okay, so now draw a tangent line. So if you observe, this is the tangent line. Draw a tangent line to the curve parallel to the x-axis. Draw a tangent line to the curve parallel to the x-axis at the lowest point of the graph. At this lowest point of the graph, we have to draw a tangent line which is parallel to the x-axis. Okay. So the point where this line cuts the y-axis gives the angle of minimum deviation. This is the angle of minimum deviation. So at this point it cuts the y-axis, and this point is called as angle of minimum deviation. It is denoted by capital D. If you observe, we can represent it with the capital D. Okay. Draw a parallel line to y-axis. Now we have to draw a parallel line to the y-axis through the point where the tangent touches the graph, and here the tangent that touches the graph, the line meets x-axis at a point showing the angle of incidence corresponding to the minimum deviation. If we do the experiment with this angle of incidence, by taking this angle of incidence, if you do the experiment or activity with this angle of incidence, we will get that angle of emergence is equal to this angle of incidence. Find the refractive index of the prism using the following equation. So now we have taken the data, and by using the data and by using the following equation, we have to find out the refractive index of the prism. What is the formula? So n is equal to sine a plus d by 2 by sine a by 2. This is the formula. N is equal to sine a plus d by 2 by sine a by 2. So where n is equal to refractive index of the prism here, a is the angle of a prism. First we have find out the angle of prism, and d is equal to angle of minimum deviation. So we got the angle of minimum deviation, and by using these values we can find the refractive index of the prism. Thank you. Thank you for watching this video.